Welcome to Chapter 1, Section 5. As you can see from the title of our notes today, we're going to go back to solving equations. However, now we're going to look at solving equations that have variables on both sides of the equal sign. So an equation, and whenever we're moving something from the left side over to the right side, we want to use those inverse operations in order to move things across the equal sign. So again, we're going to be thinking through PEMDAS when we are solving equations. We're going to be using inverse operations, working backwards, and a couple of other key concepts. Now, when an equation actually comes out to make a true statement, such as the statement 4 equals 4, we're going to call this an identity. This is an equation that is true for all values of the variable. In other words, it is said to have infinite solutions. It doesn't matter what value you put in for that variable, it will make a true statement. Then on the other hand, you have equations that have no solutions. In other words, there will be something like 4 equals 0 as a final statement, and that's never true. And therefore, that's going to imply that no value for that variable will ever make a true statement for that equation. All right, let's jump in with a few examples. Example 1, we're going to solve for that variable. Again, we're going to combine like terms by moving things across the equal sign. So I'm going to start off by adding 9x to the left side, moving that from the right side of that equal sign over to the left side. And I'm going to move the 10, that positive 10, over to the right side of the equal sign by subtracting 10. So we're going to do both of these moves here at the same time simultaneously. That will give us negative 4x plus 9x, which is 5x, and then negative 12 plus a negative 10, or in other words, negative 12 minus 10, which is negative 22. From here, we're going to solve for x by dividing both sides by 5, and that value for x is negative 5.5. Again, you should plug that value back in. You can plug it back into both sides of that equation to show that it produces a true statement. So we'd say x is equal to negative 5.5. Let's take a look at example B. Example B, we have 3 times this quantity, 3t minus 4 is equal to 1/4, 32t plus 24. In this case, it's going to make sense for us to simplify both sides of the equal sign before we start moving things across it. So let's distribute those numbers in front of the parentheses. That gives us 9t minus 12 is equal to 1/4 of 32, which is 8t, and 1/4 of 24, which is 6. All right, now we can start combining like terms. I'm going to subtract 8t over to the left here, and that gives me 1t. Simultaneously, I'm going to add 12 over to the right side of the equal sign is equal to 18. And therefore, if we divide off that 1, t is simply equal to 18. Example C, we now have 4 times the quantity of 3d plus 2 is equal to 12d. Here you could also distribute that 4 into the parentheses, or you could get rid of that 4 by dividing it over to the other side right off the bat. And that's what we'll do in this case here. It doesn't matter which method you choose here. So we have 3d plus 2 is equal to 12d divided by 4, which is 3d. Now to combine like terms, we're going to move this left side 3d over to the right side by subtraction. And we get 2 is equal to 3d minus 3d, and those are additive inverses. That means it comes out to equal 0. So we get the statement that 2 is equal to 0, and this is a false statement. 2 is never equal to 0, and therefore we say that there are no solutions to this equation. All right, in example D, we have n fourths is equal to negative n fourths minus 3. We're going to combine like terms, that's the variable n, by adding n fourths to both sides. All right, n fourths plus n fourths actually gives us 2n fourths, and that simplifies to 1/2 n is equal to negative 3. So 1/2 n is equal to negative 3. We got to get rid of that 1/2. And instead of dividing by 1/2, we're going to multiply by the reciprocal. 2 times that 1/2 will bring that coefficient back to 1, n, and therefore I'm going to multiply the negative 3 by 2 as well, and that gives me negative 6. Sorry for the little tail there. Negative 6 is my value for n. All right, let's take a look at example E. Very similar to before. We'll combine like terms on the left side of the equation before moving them across the equal sign. So we have a 3x and a positive 5x. That gives us 8x minus 12 is equal to 6x plus 14. Subtract your 6x to the left, and you have 2x. Simultaneously, we're going to add 12 over here to the right. All right, so that gives us 2x is now equal to 26. When we divide both sides by 2, we get an x value of 13. All right, and last example here for these numeric problems here, we have 5/4 x minus 7 is equal to 1/6 x plus 3. Let's start by moving the 1/6 x over to the left side of the equal sign. So we have 5/4 x minus 1/6 x. I'm just going to get rid of this guy here. And then simultaneously, we're going to add the 7 over the right. All right, now that gives us 3 plus 7, which is 10. Now to combine these fractions, these coefficient fractions here, we have to have a common denominator. And so we're going to change those to have a denominator of 12. So the equivalent fraction here would be 15/12 x minus 2/12 x is equal to 10. All right, let's combine those. 15 minus 2 is going to give me 13/12 x is equal to 10. And finally, to get that 13/12 over to the other side, we're going to multiply by that reciprocal, which is 12/13. When we multiply both sides by that reciprocal, we'll be left with 1x is equal to, that's 120, 10 times that 12, 120 over 13. And we can just leave it there as a fraction. All right, our word problem for today, we have Mr. DeLora, who likes to bike 3 hours to reach Lake Michigan. Using the same route, his return trip only took 2.5 hours because he traveled 2 miles per hour faster. How far did he bike to get to the beach? All right, well, remember our little formula, distance equals rate times time. And we're going to start off by plugging in what we know there. We want to know how far he biked to get to the beach. So we're looking for D here, our distance. Well, we have our rate, which was 3 hours. I should say our time, which was 3 hours. And then 2.5 hours because he traveled 2 miles per hour faster. So we know the distance going out to the beach took him 3 hours at some rate. And that same distance coming back took him 2.5 hours at a rate, plus 2 miles per hour faster. All right, now these are both equal to D. That distance is the same because he took the same route. So what we're going to do is we're actually going to set these two equations, 3r equal to 2.5 r plus 2. Oops, I'm going to keep that in parentheses there. Set them equal to each other. From here, we are going to combine like terms, but first we need to distribute that 2.5 in. So that gives us 3r is equal to 2.5r plus 5. And now we're going to subtract over that 2.5r. And that gives us just 0.5r is equal to 5. Finally, when we divide both sides by 0.5, we end up with a rate here of 10 miles per hour. All right, well, if we traveled at 10 miles per hour, then we wanted to find the distance. And we remember that our distance is the time times the rate. That's 3 hours at 10 miles per hour, and therefore that distance should be 30 miles. So it was a 30-mile bike trip out to the beach, and then turn around 30 miles back. I'm exhausted. And that's all for your notes for today. Have a good one.